Good morning, everybody. Welcome to class this morning. Glad you are all able to watch. Glad you are all able to join me, whether you're watching live or you're watching the recording later on. Thank you for watching. I really appreciate it. Glad you're involved and engaged and, doing your due diligence to be successful in your classes. So this week we're talking about loops. And one of the good things about this module is that this is a 2-week module, which means we got nothing to do this weekend. If you want to go ahead and get ahead, you're welcome to, That way you don't have to do quite as much a little later. But this is a 2-week module. I like to spend a little more time on loops just because of how critical this data structure is to kind of understanding and working in code. Right, because we practiced a little bit of recursion earlier on, and recursion gave us the ability to do something over and over and over again. But now we're going to start looking at loops, which is like recursion. It's similar to recursion. In most of the cases where we might use recursion, we can use a loop instead, but it's going to be a whole lot easier because it's going to give us a whole lot more flexibility. And we can do a little bit more with it without having to think quite as hard about how our data's flowing through and all that kind of fun stuff. So let's start out with a little bit of review, I guess, and just write a recursive method, shall we? So let's head over to a REPL here. Let me find where I have my REPL in my list of items here. And let's kind of review here how we can think about this by writing a recursive method. So when we were writing recursive methods earlier on, what we would do is we would write a method, write some kind of new method, which we could write this as either a void or a value method, does not really matter. Ideally, we're going to write it as, well, I guess technically we have to write our recursive methods as void methods because we have to be able to recurse the method before our return statement because that return statement is going to stop it. So we need to write this as a void method. So we can create ourselves a new method. We can, do it just like we were doing it before. Public, static, void, we'll call it R just for our purposes right now. And we can accept an argument of int x. Right, so what we said we would do in this sort of case is we'd start with a number, we'd iterate that number, and we'd check it against a condition, and as long as everything was okay and meeting the conditions, we would recurse the function by adding a self-reference to this function inside of itself, which is what a self-reference is. So we would say if x is less than 10, so if x is less than 10, we will add 1 to the value of x, x plus plus, and actually I think we'd want to go ahead and print it out first. So system.out.println x, add 1 to the value of x, and recurse the function. So R with our new value of x, so we have that self-referential recursive function call here by calling our R function inside of our R function. Else, we'll just print thank you. So system.out.println thank you. And so there we have our recursive function. All we'd have to do is call this function inside of main with a value in it. So we'd just call our R function with an argument value of, say, 1. And we'd be ready to go here. And so what this would do is it would give us our numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, up to, but not including 10, because we're doing less than but not equal to, which I guess, just for sake of argument, we could add that equal to here. So we could get the numbers 1 through 10 in our output. And so each time it's going to print out the number, move the number toward the condition that will break it, and recurse the function with that value in it until we break our condition. So once x equals 11, instead of our if condition, we'll run our else condition. And this is our recursion. So we just get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you. And so this is a recursive method. But what we're writing here is not going to be a recursive method. It's going to be a loop. And we're going, after we talk about loops a little bit, we'll go back and revisit this, and we'll write it with a while loop instead of writing it with our recursion here. And we can see the differences and we can see the changes and see how it works with one versus how it works with another. And really, when we get down to it, sort of the precipice of our while loop is based on these same types of evaluations that we're doing here. Like, we're still checking a condition and we're still incrementing our variable. Just we've taken the thought process behind how we do a recursive method and we've simplified it into our loops. So let's put a pin in this. We'll revisit this here in just a few moments. And let's look at some slides. So first off, I think we should talk about what a loop is. You know, we kind of see this sort of idea of something moving over and over and over again, you know, going in a loop. And a loop is going to do exactly what our recursive method here does, insofar as it's going to allow us to repeat a process until a condition is met. And each step through a loop is called an iteration, which is a little bit different, you know, a little bit different terminology here between recursion and our loops, because we say recursion is a recursive process, whereas a loop is an iterative process. But we can kind of think of it in the same sort of way. You know, there's no real need to like get too deep into terminology here. Like, there are differences that are significant between a recursive process and an iterative process, but for our purposes, we don't really need to worry about them. We can just keep pushing right on through. And it's great for running an input, running through an input and applying the same conditions to each part of it. Like if we're going to do a sort, which might be something that we do next week. We might look at sorting different values or something of that nature. Might be kind of interesting. But we start off our loops by looking at the while statement. There are two basic kind of loops that we'll be looking at, and we'll also be looking at one or two more advanced types of loops. But the first one we want to look at to kind of introduce us into the world of loops is our while statement. And a while loop performs an iteration while a condition is true. So as long as this is true, as long as this condition is true, our code's going to keep running. It's going to keep running. And so we can look at this sort of example while statement. And I actually have a countdown on the next screen as kind of my my visual example, and then we'll go back and we'll revisit that little recursive example that we did to start off our class this morning, to that we were using for kind of review, and rewrite that with a while loop. But we can identify the different portions of each of our while loops and our recursive process within the same sort of thing. So if we look at the next screen here we have a countdown, right? We have it all contained in its own function, which is pretty good. To simplify things, we can use a void function here, but we can also use value functions with our loops, which is going to be one of the first good things that we can do with this here, right? We're not constrained to void functions like we are with our recursive process. Because remember that, when we're using a value method, which we talked about last week, once it hits that return statement, that's going to stop the execution of that function or that method. So when you do that sort of recursive loop there, if you were going to return a value from your value method and then try to recurse it, that's going to be pretty hard. But using our value methods with our loops, a lot easier. Right? So that's one of our options here. And what we see here, though, is we see the same sorts of situations that we would do in writing a recursive method. For example, we have a condition. Now, we're not writing it as a conditional this time, but we do have a condition here. It's written as a part of our while loop. So we're saying essentially while n is greater than 0. And, we can read this out as English here, and we can kind of make sense of it in that sort of way. While n is greater than 0. As long as n is greater than 0, we are going to do the following. We're going to print out the value of n, and then we are going to increment, or in this case, decrement, our variable n. We're going to move it toward that base condition to try to break that condition. And then once we're outside of the while loop, we can write something else. So once this condition is broken via this moving of our variable, then it's going to stop and move out to the next thing that's in our code. So we can look at this in similar terms to our recursive method. So let's pop back over to that REPL really quickly. So we've got our recursive method here. I'm going to comment it out. Just give that the old comment out here. And we'll write ourselves a new method. We'll call this one method I. So for iterative. R for recursive, I for iterative. We'll write ourselves a new method here. And we'll just make it another, so we don't have to overcomplicate it here, just for our proof of concept. We'll make this a public static void I. And we'll still give it the int of x. Same situation. Right, so we want to do the same thing that we were doing here. But we want to do it with our while loop. So we have our condition here, if x is less than or equal to 10. So we're just going to pass that condition as a similar thing, but instead of thinking about it as a conditional, we're going to put it in our while statement. While x is less than or equal to 10. So while x is less than or equal to 10, as long as x is less than or equal to 10, we're going to do the following. We're going to system.out.println x, and then we're going to increment x. Now by default, as long as this condition is true, this while loop is going to keep running. So that's going to save me a line of code here. I don't have to recurse anything because this is already built into the loop. So it's going to evaluate x against the value of 10. If this statement is true, if x is less than or equal to 10, it's going to print out the value of x. It's going to add 1 or increment x. And then it's going to jump back up to the top of my while loop and keep going until this condition is no longer true. And so when that's done, all we have to do is add this other as just a simple evaluative line of code. System.out.println. Thank you. So that's the same thing done in two different ways here. Right, we have it here as our recursive method, and we have it here utilizing our while loop. And we can see the similarities, and we can see the differences. And so if we run this, if I put the function call, which is going to be I1 right here, because we want to count it 1 to 10, just like we were doing before. Then we're going to be able to see it work in exactly the same way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you. So if we took these comments off to where we have an R value, or an R function, and this I function, we can watch them both work in the exact same way. Get the exact same output. And I teach recursion first because it's better for us to understand the basis of how something works before we get into some of the other stuff. And there are some instances where only a recursive method will work. But we can see here that these are the exact same things. We're getting the exact same results. Our code is very similar. Right? Like we can even take this code and kind of outline it and look at it to where, okay, so we've got our condition. This is our condition in our while loop. This is our condition in our recursive method. We have our incrementation. So we have incrementation here, both exactly the same. The only difference is my while loop restarts automatically, whereas my recursive method restarts here. Now, what does this give us the luxury of doing? Well, with my recursive method, it's rerunning the entire method, right? So something that you all might have discovered as you were working with recursive methods, if I set a variable here, like int y equals 10, and tried to use this in some sort of way, or iterate through this number in some sort of way, every time my method would recurse and restart, it would reset this value no matter to what I changed it to. Right? Because it's running the entire code that's in my method every single time. With my while loop, it's only going to run the code. It's only going to loop the code over and over again that's inside of the while loop. That's a part of the while loop. So this gives us the luxury and the ability to come out here and write as much code as we want, declare as many variables as we need, iterate through as many different things as we need, do other calculations outside of here. We can do as much as we want without having to really think and scrutinize and work hard trying to figure out the path from point A to point B so we can use recursion to do our iteration. So it gives us a whole lot more flexibility. It gives us a whole lot of more options for how we can approach problems. And this is good. Right, so hopefully you're already starting to see how our iterative methods, how our loops are going to be way better than our recursive methods in terms of simplicity. As we're talking about a while loop here, one of the things that we can look at is we can look at the flow of execution for a while loop. And we kind of looked at it just as we did there. It's evaluating the condition in that while statement, right? We're saying while this is true, we're going to run this code. If the condition's false, it's going to skip the body of that while statement and go on to the next statement, which is what we saw there. You know, once that while condition turned false, it jumped down to that next line, which was the thank you. I didn't have to write an else statement for that because it wasn't, because otherwise that's going to be evaluated every time, or it's going to be dead code. So I didn't need an else statement. I didn't need, anything else, just after that while statement, it's just going to keep on going to the next thing. And so as long as the condition's true, it's going to jump back up to the top of that while statement and keep going. And as we're thinking about stopping a loop, we want to be able to stop a loop in the exact same way that we want to be able to stop our recursive methods. We're approaching this with this same idea that we have to move that variable to its conclusion, to a point where it's going to make our condition false. And a popular way that we can utilize our functions here, or our loops here rather, is going to be by utilizing our Boolean flags. So this is a way that you might see some while loops written. Right, so let me comment out what we have here. So we can write ourselves a brand new method here. We'll get rid of all of these method calls or function calls in our main. And let's just write ourselves a little hello world function where we'll use Boolean flags to keep repeating hello world until we're ready to stop it. And so let's write a public static void hello. Don't really need, let's take an integer in here. Int x. That'll just be how many times we decide to run it. And so ideally what we would want to do here is we would want to set our Boolean variable of say hello to true. So now we have a flag variable here of say hello, and we have it set to true by default. So we're doing what we call, and we'll mention this later in a slide, we're doing what we call here seeding the loop. We have to give our condition, we have to start our condition true so our loop starts. Right, so whatever our condition is going to be, if we want to be able to run that condition, we have to make that condition true so it starts to run. And so we can say, well, while say hello And this is just another way that we can use these while loops, right? So then we could bring our x into it with a condition, and we can say if and we'd also probably need a little counter variable here. So let's try an int counter equals 0. If counter less than x, we will print hello world. Else we will say hello and set that to false. And so this is just another way that we can format an iterative, loop, an iterative while loop within a program. This kind of gives us some more abilities to do different chained conditions if we needed to. Like we could say, if this or that, we could do one thing or another. It's just another way that you might see it written, that you might encounter it in a different way. And so while say hello essentially is just shorthand for while say hello is true. If the counter is less than this, we will print out hello world. We also need to iterate our counter, or increment our counter rather, so we can move that toward that breaking state. And so this kind of merges the two examples that we've done so far in today's lesson. It kind of presents this in something that's a little closer to recursive methods, if you're more comfortable with that now that you've had a few weeks of practice with that. But it's also still a loop, so we still have that flexibility. I can have this counter variable here. If this was a recursive method, each time my method would recurse, it would reset that counter variable to 0 and give me an infinite loop. It's not going to do that here. So this is a good example to kind of show that off. And we can just see it in action. So all we'd want to do here is we would want to invoke our method. Hello, we'll say hello 5 times. And let's clear out our console and run it. And we get hello world 5 times, right? So that's 2 different ways that we can write a while loop. We can write them with a Boolean flag like that, or we can write it with a standard condition. Either one's going to work. Either one's going to give us the ability to do iteration with a loop, with a while loop. And in both cases, we're able to stop the loop and move on to something else. Also one of the great things here is that, in this else condition, I can continue to write all sorts of code. I can do whatever I want, It's pretty nice, right? Like there's no issues here. Options, flexibility. And that's going to get us to what we want. Now, the more we've worked with while loops, the more programmers have utilized while loops, the more that we realized that we essentially use the same things in our while loop every single time. Right? Like if we look at every while loop that we've written here, we have some kind of condition, some kind of incrementation, right? Especially like when we look in something like this here, we have some kind of starting variable, like an x, some kind of incrementation, like this x++, and some kind of condition, like x is less than or equal to 10. And so after seeing, after writing while loop after while loop after while loop after while loop, essentially, us as programmers, we said, there has to be a better way. There has to be something that makes more sense. There has to be something that we can utilize that kind of gives us a bit of a shorthand here. And that's where we get our for loops. So what we decided was there has to be a more efficient way to work with a loop in our code. And so we derived the for loop. And the for loop takes all of the conditions and expressions that is required for our while loop. Like we could see the same stuff in both our for loop and our while loop. We just express them in a more concise manner. So the for loop is going to be easier to read because it takes all of the loop-related statements and puts it right at the top of the loop. Right? Like when you think about that while loop and where we have our seed variable and where we have our condition and where we have our outputs, those could be entirely separate. You could have your variable at the top of your program, the condition somewhere in the middle, and the incrementation somewhere closer to the bottom. They could all be separated out from one another. But with our for loop, we take all of these statements that we need in all of these while loops, that variable declaration, that condition, and that incrementation, and we put them all in one single statement. And so we can look at something like this, right? Now, one of the things that we're looking at here is we have this other variable that's established outside of this program here. And we can use that variable inside of our for loop, as we've done here. But we can't use the control variable, our loop control variable, outside of the loop. That is this bad boy right here. We need this loop control variable. That's sort of our seed variable that we would use in our while loop. We need this loop control variable to give our loop a starting point. But this variable is going to be scoped for this loop. So I can take a variable from outside of my loop and use it inside of my loop, but I can't go the other way. I can't go from inside of my loop and try to use it outside of my loop. If I tried to reference I somewhere down here outside of my loop, my program's going to have no idea what I'm talking about. Then I've got, here's my condition, here's my incrementation, and here we have the body where we're executing something each time. We are going to print out the value of I to the whateverth power. So it'd be I to the first power, I to the second power, I to the third power, I to the fourth power, so on and so forth. Right, just each time, and that's between 0 and our unknown break condition here, which is n. We don't have that demonstrated for us here in this little code sample. Flow of execution here is going to be almost exactly the same. The initializer is going to run once at the very beginning of the loop. The condition is going to be checked each time through the loop. If it's false, the loop ends. If it's true, it jumps back up to the top of that for loop and keeps going. And at the end of each iteration, we're just going back to check the condition again. Right? It's essentially exactly the same. So I tell you what we'll do, because we're about ready to wrap up here. Let's do a little bit of a a little bit of a different type of program here. We're still kind of doing this proof of concept here, but what I'd like to do is I'd like to do a little more of an involved proof of concept to get us something. And in order to do that, we will use like a return statement. We'll use a value method instead of a void method, just so we can see another instance in which we can use this sort of thing. So let's just do a little bit of coding here. Let's just have a little fun. We'll comment this out. So now when I give you this demo file along with the recording today, you'll have all of this example code in there as well. I'm going to write myself a new function here. And we'll just make this a private function. Let's just, so we can practice our private int countdown. Int I. And remember, when we're writing value functions, we want to start out with our stub. So we will add a return 0 here to complete our stub and give ourselves a little return statement here. And so what I want to do in order to do this, because this is going to be a little bit different, right? Because if I want to print out every line, I'm not really going to be able to do it in this method. So what we're going to do here, and really countdown isn't a great... We'll call it, let's call this sum numbers. Because countdown wasn't really a great name for that. What I want to do here is I want to be able to have like a finishing point, which is going to be I, and I want to be able to add together all of the numbers between 1 and I. That's the goal that I want to have for my program. So what I'm going to do is I'm going to create myself a little temporary holding variable here. We'll call it int sum. And so right now that's just going to be 0, but it's what we're going to return out of here. And we'll say 4 int n equals 1. N is less than or equal to I n plus plus. Right, so this is all of our loop conditions here. We have our variable, we have our loop counter, we have our condition, and we have our incrementation. What we'll do is we'll go ahead and print out the value of n. So we'll system.out.print line n. Or actually, just system.out.print might be a little nicer here. And then we can put a little, we can concatenate that with a little space, just so we can have everything on the same line. Right? So instead of doing line by line by line, 1, 2, 3, 4, 5, 6, 7, 8, whatever, we can put them all on the same line. And then we can take our sum value and add the value of n to it, just so it has like a rolling count. right? So 1, and then, so the first time through it'll add 1 to sum, the second time through it'll add 2 to sum, so on and so forth. So sum plus equals n. We'll set sum here to 0. Sum plus equals n. So this will allow us to print out every number between 1 and our condition here on a single line, and give us a rolling count or a rolling sum of 1 plus 2 plus 3 plus 4, so on and so forth. And then we will return sum. So now we can work this into our main method. In fact, let's just go ahead and make this like a fully fleshed out program, right? Let's go ahead and import scanner. So import java.util.scanner. Let's initialize our scanner at the class level. So that's going to be public final scanner n equals new scanner system.in. And if that's a little confusing to you, go back and watch last week's live stream. We talk about this stuff in there. So now we can put all of this stuff in our main. We'll have to create an object so we can both access this scanner that we have at our class level and this private value method that we've made here. So let us system, so this is our class is main, so that's main. We'll give it a name like obj equals new main. So now we have this main, so we can create copies of these other functions and things in memory so that we can have this polymorphism going on here. You know, we don't, that's a term that we don't define, but that's kind of what we're doing. And so then we can give our user a message, system.out.print, enter number to count. You know, maybe to which to count. Take and pass int finish equals obj.n.next int. Then maybe we want to take an int total equals some numbers with finish. And then we can system.out.println the total of the previously listed numbers is colon, and concatenate that with the value of total there. Total. So now we have this complete little program here. We have our red squiggle here under some numbers. That's because it's a private function, so we can't access that without utilizing our object, obj dot. Now that little red squiggle goes away, and we're all good. So what we should expect to be able to do here is enter a whole number to which to count. We should expect to see counted out 1 through whatever our number is, and then we should get the sum of all of those numbers from that we have listed. So we can clear this out and we can run this now. Enter a number to which to count. Let's try 12. I believe 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 is somewhere around 78. Right, so like 2 and 3 and 5 is 10, 4 and 6 is 10, that's 20. That's 35, 44, 54, 66, 7, 8. Yeah. So we're good. We're good there. That looks like it's working pretty good. Such as it is, I think. So we have a working program here that's going to get us what we want. So since this is a 2-week module, we can go ahead and stop for this week. Stop a little early. Stop before having an hour and 15-minute live stream. So next week, we'll approach this again. We'll do some more stuff with loops. We'll talk about loops a little more. We'll do a little more advanced example. But I think this is going to give us a good start toward loops. If you go ahead and get started on your assignments and looking through your code, or if you have questions, go ahead and send them in to me. Because one of the great things is that, since this is a 2-week module, I can not only address the answers to you, but I can address the answers to everybody, because we'll have another live stream on loops next week. So this is where we'll stop for this week. I'm going to hang out and chat for a couple minutes with the music playing, just in case anybody in the chat has any questions for me for today. But that's all that we have for today. Thank you for watching, and we'll see you next time.